So that is the idea of Zookeeper and any other distributed apps. Explanation for Zookeeper was whether it's a distributed log server. It's not. That's not the case. But it's a distributed log server. It provides that feature with Zookeeper, so one can implement that. So we'll talk about that later. So basically, it provides these services. It provides high availability, scalability, distributed configuration management, and agreement, group membership. So whatever the services, distributed services which needed. So someone may ask why we need the Zookeeper. So if you try to implement these services, it will be very hectic. It's like you write an app, you don't care about authentication anymore, right? You have ID. So likewise, you have Zookeeper to handle these services. So with this, it will be easy to manage applications, and it doesn't lead to any complexity because Zookeeper has encapsulated all the complexity conditions. And it's an Apache project, and originally it was from Yahoo Research, and they donated it somewhere in 2003. And this is basically a simple file system. It's kind of a file system, and it has a basic operation API which we will talk. And this provides full read and full write. So there's no partial read and partial write. And also you can't rename this. Either you write or you rewrite. That's it. So it's an ordered update in the sense that if the client follows an order when writing or when persisting data, so that is followed throughout the cluster, Zookeeper or on Zookeeper Ensemble. And the persistent guarantees means that the client knows, okay, for sure, okay, this data update is seen by majority of the Ensemble. So we will talk about this, what is majority, what is Ensemble, data, section. And the other point is watchers. So this provides a mechanism for data change. Like there are clients listening to this cluster, and if one client do a change, that change is informed to all clients who watch us, particularly for that change. And there is one type of node. So it's called ephemeral nodes. We'll talk about that. And I explained why Zookeeper in it. So in overall idea, so this simplifies the process of coordination in distribution system, but it does not eliminate any of the keys of Zookeeper. So it's sequential consistent. So that means update from one client will be applied in the order that they were sent, and automacy. So that means updates either succeed or fail. So if a client writes, if I try to write for a particular node, that will be success or not. It will not. There won't be partial writes. So it has a single system image. So a client will see the same view of the service regardless of which server it has been connected. So it's very reliable, and the client within the system is guaranteed to be up to date. So let's talk about the data model. So as I mentioned that this data model is more like a file system. So it's a hierarchical namespace. So you have the root node here. So just like folder maybe, and you create these are child nodes, and I think that within that you have more child nodes or data nodes. So these nodes are called Z nodes. That means the Zookeeper nodes. So that's a term which you use. So this node can have children, or there can be associated data with that. So usually this data we call stack. So this stack would have version numbers of changes, and also any controls, access control list, and also the cache validations, etc. So so that's very important when cluster monitoring, if you are monitoring clusters. So ephemeral nodes are like temporary nodes. Like this node will be created when a client establishes a session with the Zookeeper cluster. So once the connection is terminated, this node will be also deleted. So this is one of the important features. Because of this type of Z nodes, it is possible to implement some of the use cases which we will talk later. Very simple. So it has a create API. So basically this will create a path in the file system. It will create a Z node basically. So given the path name and the data. So for example, if we give the path name this and some data, so it will create this particular node. And delete, given path name, so the node will be deleted. And in the third API, it checks whether this particular node exists or not. So if it exists, the stat, which I talked before, that the stat object will be returned. If stat is null, that means that path is that node is not available. So we can set data. Already, let's say in the first call we create a Z node, but without any data. In this call we can set data. So this is used in cluster management. Like let's say if a node has joined the cluster, so I want to update my CPU and memory count to the cluster. So we can use this API. So get data is you will get the data, and get children. So what are the children nodes of this particular parent node? And sync. So sync is kind of important. So Zookeeper does not guarantee, like for example, let's say a one node writes, it does not guarantee at the same time every node will see the change. So in that case, clients can use this sync call. So he can wait for some time, he can wait, and then after some time you will get the after service. So basically, Zookeeper, when you up the Zookeeper, there can be two. You can up the Zookeeper in two ways. One is the standalone mode. So that means there's only one Zookeeper node. The other one is a cluster node. So in cluster you have multiple nodes. So at the startup, a leader is selected among the Zookeeper. So suppose this is the Zookeeper cluster. So this guy has now it has been elected as the leader. So once it is done, so all these server will store a copy of the data. So these data are the data files, the snapshots, and some log files in the memory. So by doing this, there are like pros and cons. The pros, obviously, it will improve the throughput and reduce the latency. And the disadvantage is that you can't have if you take data, you can't have like large data in the Zookeeper cluster. So it's limited by its memory. So for this, Zookeeper has introduced a lock or check within it that you can't have let's say more than 1 MB of data in a particular node. So anyway, this is customized, but administrator can change that, but usually that's a default value. So the client knows, okay, so these nodes in the cluster are fixed. So there's no dynamic membership, like it's a static. So if a client wants to use the Zookeeper service, then he knows what are the 5 URL or hosts to all the Zookeeper servers. So he connect randomly with one of the nodes and he read data. So it's very guaranteed that it's up-to-date data. So if he wants to write that, if this client wants to write data, it doesn't write to that particular server. So because this server knows what is the leader, so that task is delegated to the leader. So leader is the one who actually write data, and the read is done by the client can read from any servers. The other important is the ensemble size. So in Zookeeper, if there is more than one server, so that means it form a cluster. So we usually the practice is to have a odd number of servers in the cluster. So there was a reason, like if it is an even number, then the quorum is not 4. So there won't be a majority like when doing a failures. For example, let's say in 3 nodes, in 3-node cluster, so if one node fails, still the cluster can serve the clients. So it allows only one failure. So suppose there are 4 nodes, so if one failure, then it can the 3 nodes can support the clients. If another node failure, so that means now 2 is there out of 4. It is not a majority. So you need to have a more than 50%. So that's the quorum. So there's no benefit by having 3 and 4 cluster. It's basically same. So that's why dot number is preferred. So at Leapset we use 3-node cluster. So the optimal one was the 5 Zookeeper cluster. So these are the some of use cases. The lead election. So a client can use the Zookeeper cluster to elect a leader of themselves and a group membership, some work queues like a particular node or particular server can put tasks for this queue, and a monitor will take one task and assign to a particular client to execute. So that kind of work can be done. It can do configuration management like what Solar does. In Solar, the configurations are like persisted in Zookeeper hierarchy. So that is shared among the Solar nodes. And cluster management like if there are like thousands of nodes, so from one go we can see who are the nodes which are currently up and running using this API, using Zookeeper. And load balancing or distributed blocks also can be done. So I'll do a small demo on lead election. So first I'll go some in detail. So this is one of the way to do lead election. So we get data of particular path 0. If this data is available, that means already a lead is there. If not, we create this path with with whatever the host name, and that particular node will become the leader. So this is one approach. So I'll show you another one in a demo.
Thanks, Azeem. So we look at a couple more use cases. Briefly, one is cluster management. So basically, what happens is that the nodes in the cluster we will have to come to a pre-agreement on what sort of hierarchy that they'll maintain their nodes on. So here we have the root, then we have a node called the cluster name. I have named example cluster, and then we have children of that. The Z nodes being named after they are not named but ABC depending on their name. So whenever a client joins the cluster, it will create a node for himself. Namely, if the client is A, it will create a node named node A as a child of the example cluster node. So what will happen is that there will be a monitoring process of some sort to detect the changes in the cluster, to determine how many clients are connected to the cluster, what are the statuses, and everything that. So it will be watching the example cluster node, and whenever a new node is added, it will get informed. So it will get informed, and then it will know, okay, a new client is added. Now the number of clients in the cluster or number of nodes in the cluster is increased. So the client will keep updating its node. That means if the node is the client is node A, it will keep updating node A with its state changes, memory, CPU, or whatever other changes. So all these changes will be watched by the monitoring process, and it will know the status. So it will know what new clients were added, what new clients became inactive and got removed from the cluster, what were the stages. This is basically something like a certain set of nodes or clients are there which want certain tasks done, but they are not doing it. There are another set of clients which do the task. They are the worker threads. So there should be a way of communicating or assigning those tasks from the task creators to the task executors. So what happens is that this is just an example. The configuration, the implementing people can have whatever configuration they like. It's just an example. They can have a node called tasks, and whenever the task creators want a task executed, they will create a child node under the task node called task 1 or 2 with the details of the task, and there will be a supervisor process which will be watching the tasks node, and once a task is submitted, it will receive the task, and based on whatever the client logic, it will get the task. And based on the client logic, whatever it is, it can be anything depending on the requirement, it will assign to the worker thread. Now here we have another node called machine at the same level as task, and it has a child node called M1. That's the node for the first worker thread. And it will be watching its own, so the first worker thread will be watching the M1 node. So whenever a task is assigned to M1 node, it will get informed that, okay, I have a new task to be executed, and it will execute that, and afterwards it will delete task 1 node from both places. So the monitoring process or the supervisor will know that the task is executed, it is completed, and it can do whatever it likes, maybe inform the task creator. So those are a couple of use cases. So basically, each and every one of these use cases, what it does is the use case should be matched or aligned with the data model of Zookeeper. This particular data model where you have child nodes one by one, and if you can align your use case to this data model, you can get the task done. The developer says that most companies or clients who use Zookeeper eventually forget that they are using Zookeeper because it doesn't come up, the issues doesn't come up. There aren't any problems, so they eventually forget. The Zookeeper runs underneath very smoothly, so there isn't basically not to monitor. But if and when an issue comes up, these monitoring tools will come in handy. You can log into Zookeeper, and there are a set of commands, like 4-letter commands that you can execute and get the status of the Zookeeper server. Like for example, one is conf conf, which will give you the server configurations, and then you have something called dump dump, which will give you the outstanding sessions and list of ephemeral nodes. There are a lot of other things like that. Then it has JMX support as well, Java support, so that can come in very handy. Then you have basic login support as well. And they say in a future release, they'll have a Jetty-based monitoring solution which will eventually replace Zookeeper commands, and you might be able to get JSON and XML-based results as if you want. So that would be more user-friendly than Zookeeper commands. And when it comes to maintenance, again, if you don't need monitoring, you obviously don't need much of maintenance as well. one thing is that in earlier versions, you had to ensure that the data directory inside Zookeeper servers had to be cleaned from time to time. This is where Zookeeper stores its snapshots and write-ahead logs and everything. So it had to be cleaned from time to time. From version 3.4 onwards, they have this auto purge functionality where you can specify a time interval and the auto purge cron job will be purging the data directory. So that's there. And basically the rest is automatic. Whenever say you have a cluster of Zookeeper servers, you take one down for maintenance or something goes down because of hard disk or something, you get a new server up and you do the basic configurations and put it into the cluster, and once it's up and running, it will get the necessary the remainder of the data or the configurations from the leader and start running. So who actually uses Zookeeper? As you can see, Yahoo, Twitter, YouTube, basically all the leading well-known companies are using Zookeeper. Airbnb is probably the least heard of out of these. It's an accommodation provider. You can go in and book or reserve lodges and stuff like that. Facebook actually not only uses Zookeeper, it actually actively participates in code commits or fixes and feature releases Zookeeper. So that's a huge plus for Zookeeper, although it's being an Apache project. And of course, Leapset is there. So Leapset, I think we covered all the Zookeeper usages within Leapset. Correct me if I'm missing something here. So in the platform team, we manage our schedulers through Zookeeper and we manage our Solar cluster through Zookeeper. So in the scheduler, managing scheduler means we are using it for leader election. So as Azeem mentioned earlier, the scheduler is doing certain tasks like detecting the online emergence and offline emergence and updating the database from time to time. Or it might be running another scheduled job to identify unscheduled restarts in client merchants and send out alert mails. So those kind of tasks, although it being highly available, if those kind of tasks are done by two or more schedulers at the same time, you will get unnecessary mails, redundant mails. So only one scheduler should be doing this task. So although it being highly available, only one scheduler will be doing this task at a certain time. So we are using Zookeeper to elect a leader at a given point, and that leader will be doing that task. So in Solar, it's not leader election, it's configuration management. You submit your data, and the data gets distributed between all the Solar servers through Zookeeper. And whenever a client wants to get some data from Solar, it will connect to whatever client and get the data. So and then the data and infrastructure team uses Zookeeper as well for Hadoop. Then they have a Hadoop solution. They have and a strong cluster as well. So yeah, I'm not very familiar with the details, but they use Zookeeper. And then this is a basic diagram of our scheduler and Solar servers, and Zookeeper nodes are connected or interacting with each other. We basically have 3 Zookeeper nodes, as I mentioned earlier, and we have 3 schedulers. They interact with each other in this manner. For rows done and dusted, we talk about limitations a little bit. One problem with Zookeeper is that its horizontal scalability is not recommended. They don't recommend horizontal scalability much more. As I mentioned, the number of optimal nodes for for production usage is 5. So going more than that, I mean it would work with 10, it would work with 15, it would work with 25. But if you are thinking that increasing the number of Zookeeper nodes will give you a performance improvement, that's false. That's not going to happen. It's basically Zookeeper is there to increase your reliability of your work. It's not there to increase your performance. Increasing performance should be maintained by you, by the way you write your code, by your infrastructure and everything. Zookeeper is there to increase your reliability. So there are the limitations like the maximum sessions that can be connected, maximum operations per second. Those the Zookeeper developers are saying that they are continuing to do this. And there is this max data size limitation as well for single call. Their default value is 1 megabyte. That is configurable. The optimal size, I think, as per their configurations, that's the optimal size. That's what they recommend. But that doesn't mean that a call with 2 MB is going to fail, a call with 10 MB is going to fail. It means that probably a call with maybe 1 GB might run into problems. That's what they say. The Zookeeper developers are saying is that what they say is that if your requirements are in the area of 1 or 2 GB data calls, maybe you should go to a different solution. And there's the complexity. If you are not really familiar with Java, if you are not really familiar with Apache projects, maybe if your use case is really small, maybe you might think that Zookeeper is too heavy, too complex to run and maintain. So that's not a real disadvantage that goes across all the clients, but certain clients might feel that. And then we look at a few competitors, so alternatives to Zookeeper. There is User, Accord, ETCD, and Console. I think I'm not sure whether I'm pronouncing it correctly. Let's say it's Console. User, well, it has two grave disadvantages. One is their interactions between their servers and server clients interactions are insecure. That's what the people who compare user with other products are saying. And basically, project is that there are no commits. The community is basically inactive, so that's not a very good solution. And there's another solution called Accord. So what Zookeeper is saying is that their ideal scenario, the ideal way of the ideal expectancy is that the calls they receive is 80% of the calls they receive are read calls and 20% of them are write calls. That's the ideal or the scenario where optimal performance can be gained from Zookeeper. So basically, the problem is that whenever you read, it doesn't matter whichever Zookeeper node you are connecting to, you will get the data. But when you try to write, it should go through the lead. That's how it is configured. And there are certain tasks where a majority of vote is needed. So if you have a large cluster of Zookeeper nodes, taking a vote out of each one will probably take some time. So to get the optimal behavior, what they expect is 20% of reads, 20% of writes and 80% of reads. But if your requirements is different to that, if you have more write intensive loads than read intensive loads, you can go with Accord. And then we have ETCD, which doesn't seemingly have any glaring defect or anything, which is pretty widely used as well. And then we have something called console again. Both all of user etc and console are written in Go language. And whenever you visit the internet community, they say it's better than Zookeeper simply because it's written in Go language. Zookeeper is written. Yeah, so that basically covers what we want to do.